Good morning, everyone. My name is Neeraj Zaveri, and I'm a Business Development Manager in AWS Cloud Economics. Today, we'll walk through the Cloud Value Framework, which outlines how customers are achieving value on AWS. You can use this same framework for building a business case. Cloud Economics generally helps customers understand the business value they can achieve on the AWS platform. One of those key elements is understanding the total cost of ownership difference between what they're doing today on-premise versus on AWS. So in today's session, we'll discuss these other areas of value, but focus on cost savings as this tends to be the first area customers explore around a business case for change. In addition, we'll focus on defining what total cost of ownership truly means. In December, we acquired TSO Logic. The intent is to really help customers better understand what their infrastructure footprint looks like today, including actual utilization levels and modeling what it looks like on AWS. The result of the analysis is a cost comparison, but provides customers real insights into utilization of their hardware assets. To that end, I'm excited to have a new peer of mine, Gabe Weeb, walk through how TSO Logic can help customers understand what their infrastructure looks like and make better informed decisions. So let's walk through value we typically see achieved on the AWS platform. Customers realize value in many ways on AWS. In 2017, customers started to challenge us in cloud economics to include more holistic benefits in business cases. Essentially, customers were asking us to dive deeper into better articulating and quantifying the value they can expect to achieve by using AWS. The Cloud Value Framework is the output of research identifying these common areas of value. It's the output of hundreds of business case engagements, researching thousands of existing studies, working with 2 independent research firms, and testing with 50 enterprise customers. The first area of value is cost savings. Cost savings refers to the total cost of ownership, TCO, reduction by moving to the cloud. This includes compute, storage, and network cost savings. Leveraging the benefits of elasticity, scale, and right sizing drives significant cost savings. IDC confirms this area, stating a 31% lower cost across the 27 organizations they analyzed. Customers also capture value around their teams being more productive on the AWS platform versus their traditional infrastructure, or what we call staff productivity. Staff productivity refers to the FTE productivity gained from reducing or eliminating time spent on tasks no longer needed with the cloud. Traditional legacy IT operations, including hardware procurement, refresh projects, installing, repairing, maintaining hardware, patching and updating operating systems, facilities management, and more, are eliminated or significantly reduced. IDC confirms this by highlighting a 62% more efficient IT infrastructure staff once customers have migrated to AWS. The third area is around operational resilience. Operational resilience refers to the benefit of improved security and availability. AWS customers reduce their downtime from the stability, scalability, reliability, and security of the AWS environment. Nucleus Research found a 32% reduction in unplanned downtime across the 198 customers it surveyed. And finally, and most importantly, we have business agility. Business agility is the benefit from being able to innovate more and respond faster. AWS enables customers to reduce time to market, develop more applications, update applications more frequently, and improve software quality. When executives speak about business transformation, what they're trying to achieve is business agility. In the IDC study I referred to before, they found that 47% of cloud value is around business agility. Now, while each of these areas are important, it's also really important to think about the strategic value that these areas have to your business. While cost savings directly impacts margins, as we move to the right, we see the value to the business increase, as does the ability to inspire your organization to act. Now, as discussed, today we're going to focus on the cost savings pillar of value. Let's walk through how to think about modeling out a true total cost of ownership. When modeling out costs, it's important to include all the major factors of running an infrastructure on-prem compared to on AWS. Oftentimes, when we work with customers, they'll have a good gauge on the raw cost to procure a server or storage, but not great data on standing that server up, including the cost of the rack, switches, and perpetual maintenance. This is further complicated when it comes to modeling software costs, and even more exacerbated when we factor in costs like space, power, and cooling. In addition, customers have to go through the same exercise around hardware elements like storage and network costs when they're factoring in the total cost of ownership of running the infrastructure on-premise. The essence of the cost savings advantage customers have on AWS fundamentally comes down to flexibility and simplifying the capacity planning and procurement processes. Let's walk through an example. A customer has a new application. There is an estimate of future peak consumption during this period of time. Next, the customer has to purchase, deploy, and eventually use and maintain this infrastructure. We've seen customer cycles to stand up this infrastructure take 3, 6, even 9 months. Now the application is running, and the gray line here actually reflects peak consumption. Now the delta between the gray line and the blue line here represents an opportunity cost. Essentially, it's an investment the organization has made that's gone unused. Now, for organizations that run really, really lean, we have the opposite issue. We've gone past the capacity infrastructure can handle, which means a severe slowdown, an application outage, and IT staff being paged at 2 a.m. The reality is no one wants this situation. What we tend to see is that customers estimate their peak usage and add an additional 25 to 50% buffer to avoid this issue. In fact, it's why the National Resource Defense Council states that average data center utilization is between 12 and 18%. And this is the power of AWS. It's about matching supply to demand to meet application needs more efficiently than was ever possible on an on-premise infrastructure. So TSO Logic took this analysis a step further. They looked at over 100,000 on-premise instances deployed across 20 companies that were evaluating a cloud migration. These organizations range in size from a few hundred to a few thousand employees and span multiple industries. The analysis captured hundreds of millions of data points over 6 months to really develop a fine-grained model of real-world OS utilization, usage, and provisioning levels. What the team found was that 16% of OS instances were sized appropriately for their workloads. That means a full 84% of the instances could run on a smaller footprint without business interruption. The team then looked at right-sizing those instances on the cloud and looking at the savings that results. In this study, they found that by better matching supply and demand, customers could drive an 36% cost savings. Now, this would be difficult, if not impossible, to manage on-premise, but it's a powerful mechanism for cost savings on AWS, as Gabe will show.
Thanks, Neeraj. As you said, my name is Gabriel, and I am a Senior Product Manager with Amazon Web Services. I've had the pleasure of being part of TSO Logic for the last 6 years and part of the AWS team for the last 3 months. So what does TSO Logic do? Really, we come in at the early phases of considering cloud, usually when people like yourself have been asked by their C-level executives, say, why have we not talked about cloud yet? So we come in and we start looking at it from a financial lens. We say, what are the ways to go to cloud? And are there ways that we can leverage our licensing and assets we already have? So first off, we start off by looking at all of the assets you have on premise. That's really just looking at inventory. And inventory comes from such a variety of sources. We want to understand how things are provisioned, what organizations use them, and what logical environments are assets associated with. Assets in your environment, such as dev test or QA, are probably treated differently than your production workloads that your end customers see. And in order to do that, we can either use data you already have or our agentless collector. Once we understand your current state of affairs, we'll help you build a plan to AWS. We do that through multiple what-if scenarios where we can control for things such as working more in an OpEx versus CapEx model, right-sizing your resources, as we saw earlier, based upon actual utilization, and considering different ways of doing with licensing. So going back to that data ingestion, this is where people really get scared. And I know I've seen this with over 100 different customers I've had the pleasure of working with during my time. The first area that we want to look at is leveraging our library of benchmarking costs. We know from talking to our customers that not every IT person really is focused on their costs. You're measured on uptime and durability of your services. So we help with that. We'll be able to provide annualized average industry costs for your compute, storage, operating system licenses, and software licenses such as SQL Server. This coupled in with average building and infrastructure costs and facility costs really help paint a picture around what your costs could look like. Of course, these are industry numbers, and those can be overwritten in the tooling if need be. With that set of baselines in place, now we start layering in your particulars. With TSO Logic Service, we do not want to reinvent the wheel. If you already have data being collected about your environment, which probably you have, we want to take it and reduce the friction of your experience. We see customers running application performance monitors such as New Relic. They may have a CMDB, which could be a simple spreadsheet, all the way through something larger like ServiceNow or Remedy. They may have used some sort of application dependency service such as Risk Networks, or maybe they're only comfortable with tooling such as from RV Tools, which is another product that we see in the field. All of these are wonderful ways of giving us self-reported data with very little effort from your point of view. Now, we also support the ability to deploy an agentless collector. This is a standalone Windows application that sits within your network and leverages read-only credentials of assets to talk to assets you already have. So vSphere Web API, SNMP, WMI, these just pull and collect data, persist on a local encrypted database, and then automatically sync to the TSO Logic's analytics engine running on AWS. Installing this collector is usually well within an hour, and it gives us real-time, real resolution of utilization patterns, which, as you saw earlier, understanding utilization workloads really help with the right-sizing exercise. So basically, lots of benefits from both strategies. Running collector gives us really clean resolution of data. Self-reported just makes it easier and provides a quicker turnaround and really saves effort as far as leveraging the data you already have. Since this is a very technical audience, I wanted to provide a little bit of a network diagram of how data flows into the TSO Logic engine. Every customer of ours has their own S3 bucket, which is encrypted, leveraging personal certificate. Only your data can be seen by either your account manager or yourself. We have customers that leverage our collector, and we get data uploaded every day into the bucket securely. also will take in static data from SolarWind, Risk Networks, or your Excel files. So now let's see this in action. In this environment, I want to walk through a use case where a company that has aging infrastructure wants to understand what the costs would be for moving to Amazon Web Services. They have around 800 virtual machines and physical servers split between 2 different data centers. And they're really coming to the following 5 questions. First, what exactly do I have? Infrastructure comes up, comes down regularly within enterprises. People buy assets, put it on the network, and then they maybe forget about it. People leave the organization, people switch teams. It's really good to understand, what do I actually have? Also, how much of this assets am I actually using? Not always is that the first responsibility of the IT environment, is to really keep eyes on its being used. As long as it's not redlining, everybody's happy. We like to look at costing. So I have this infrastructure. How much does it actually cost me per year to keep it as status quo? Also, what were some different models around how this infrastructure could be run on Amazon Web Services? And then the 5th one is usually a secondary question, but usually something that comes in from the more accounting side, where they say, you bought all those SQL Server licenses 2 years ago. What's going to happen with them? Can we use those there? And it's good to have an answer for that. So let's walk through those different questions. So now what we're going to do is take a look at an environment. So here we are. This is the first thing that I like to bring customers to when they first take a look at our tooling. And we call this the cross-silo report. Since TSO Logic brings in data from multiple different sources, in this case talking to VMware, pulling in a flat CMD export, the data doesn't always match. We know CMDBs get out of date. We know VMs get created without going through the regular proper process, so they're not documented. This gives us a good bird's eye view across all the data TSO Logic collected to see how much in line are the bits of data. So for this customer, we have found owners for 92% of their virtual machines. That meant we found a VM or a server within their CMDB that matched the names and specs of the VM that we discovered. So 8% of the VMs didn't have an owner. That may not seem a lot, but depending on the customer, they may want to drive that more towards 100% coverage, because they may do some analysis based upon logical environments. It's really up to you how important this data needs to agree. So we work with you to decide what's important and what's not material. We also, just as much as what we collected as for real within your environment, we want to look at how your CMDB sees things. This is important because sometimes there's environments that are forgot to be monitored. We'll go into a customer, we'll deploy our collector, we'll pull from a few vCenters, we'll come to the screen and we'll find out the CMDB has thousands of servers that were not captured, and they realize, oh wait, I need that environment. That's critical to my business. So we'll come here, we'll be able to show, you know what, we found only 11 servers that were in the CMDB that we couldn't find with your environment. The customer's like, yeah, that's completely fine. CMDB is a little outdated, no problem, let's move on. Really important to get that, make sure everybody's in alignment. The next thing I like to do is come through here and just take a look at some utilization patterns. You'll notice on the side here, the TSO Logic platforming automatically looked at the data and created some projections and filters based upon the tags of what we were pushed in through the CMDB as well as what we discovered. So in this case here, the development environment has a utilization pattern, under 20% for CPU, probably pretty normal. It looks like they're a little slower on the weekend, whereas their production environment looks a little hotter, but nothing is pinning out and still a little quieter on the weekend. This is all passing the normal sniff test. So we're usually pretty good now to start looking at how the tooling is classifying your workload, as well as the costing that was applied. That's where we look at our usage and cost report. The usage and cost report really brings a contextual view of how the tooling has classified your workload, i.e., did it think those servers were in use or sitting idle, and how much cost it associated with each of those assets. TSO Logic starts off with physical asset costing and then projects it down to the VMs running underneath. So if you think of a server costing you $10,000 a year and there are 10 VMs on it, each one of those VMs takes a portion of the cost. And then we can roll that back up between any of these pivots, whether it be logical environments. Sometimes customers are really interested about breaking down costs by departments or business units, or breaking down costs by different workloads within their environment. And each application quite often is run between multiple logical environments, and then we could take a look within there. So everything is contextual, and the test environment for this application is built across multiple virtual machines and some bare metals. Everything just gets brought down to that baseline server and then can be rolled up again. As you saw, this area here updates continually. So let's roll up to, quite often we'll look at an environment such as production. In this case, 84% of the time, the servers associated with production were doing meaningful work. That's a really good sign. That means these servers are really good candidates for moving over, and we're going to move everything over. This isn't a measure of how much it was used, but it was in use and provided business value to your organization. When we look at something like development, we're going to see a little bit different story. It's going to be in use a lot less time, idle a lot more time, and there's usually a greater chance of what we call our zombie servers. These are servers that during the entire period of data collection, whether that be the data you provide us through flat files or it was monitored by the collector, these are servers that saw no workload at all. So for this company, within their, as we can roll up to the top level of their environment, they've got over almost $500,000 worth of servers sitting doing nothing, at least during the time we reported that we collected data. We also have around $1 million worth of DR infrastructure. Of course, when we start moving to cloud, DR becomes even a different story because there's so many different strategies compared to having hot standby, since the rapid ability to spin up infrastructure. So that's a secondary discussion that can be taken with your account manager. But this gives us a really good idea of how much of the time infrastructure was used, how much was idle, and how much of your infrastructure was sitting as usually disaster recovery is idle, things that are expected to be idle. Now, at this point, the conversation is, I now know what I have. I now can qualify and quantify how much I'm using my assets, and I've got a good idea of what my status quo is. Once all those three things are in line between yourself, your account manager, and potentially your TSO Logic account or solutions architect, or quite often cloud economics. If your environment is really big, quite often cloud economics gets brought in to help along. We can move into the fun stuff, which is the future state modeling. That's where we take what we saw and make fun things to look for how it could look like in the future. So what we do is we jump into the cost modeler. And the first thing I see customers doing is create a scenario where they replicate their current purchase strategy, which is a very CapEx model. I'm going to buy some things. I'm going to use it to its fullest for 3 or so years. I'm going to see what that costs me. So what we're going to do is create a scenario. And this will be our test one. This is our CapEx model. As we know, different regions within Amazon have different infrastructure. Not all regions have every possible instance. We'll want to make sure we model to the region that makes sense for you. Oregon's always fine for us. We can take a look at how we would want to purchase this infrastructure. So all up front 3 year is a very CapEx type model. And then we're just going to stick with all the defaults. This includes right sizing, which I'll dig into a little bit later at exactly what we saw, and repurchasing everything as close as to what you have on-prem. That's great. So there we go. There's the model. Now, the first things you're going to see are some numbers here around if we were to directly lift and shift the infrastructure as provisioned on premises to AWS, quite often it's the same or sometimes a little bit more. And that's really not always just from an infrastructure, it's usually not the same. But when we start looking at licensing, quite often licensing is the kind of the tipper. So in this environment here, we actually see quite a bit of a lift for going direct match. But once we start looking at right sizing those resources, matching your utilization patterns to the assets available within the AWS catalog, we can see some dramatic improvements. So the first thing you'll notice is that 164 servers were just zombies. They weren't used. So the model is recommending don't bring them over yet. You can change that within your configuration, but we provide you those toolings to say, don't bring over things you're not using. We also show how much storage you'll be bringing over, as well as how many cores of different licenses you are repurchasing from the Amazon Web Services catalog. Now, that may start off interesting, and already we're seeing a savings, but this is where you remember your conversation with your accountants, with your accountant side, and you want to say, you know what, I have already procured a whole bunch of SQL licenses. What happens if I want to do that, bring them over? So test 2, we're going to do another CapEx, but I'm going to bring my licenses over. So we're going to keep exactly the same configurations, but we're going to say, I know my Microsoft EA, I pay for software assurance, and my accounting team says that on average, we prorate or we amortize out our SQL Enterprise licenses to be around $3,300 a year, around $900 a year for our standard, and web is usually pretty cheap, around $100 or $200. Everything else is the same. Now, depending on how your organization manages your books around capital expenditures with licenses, these numbers are going to dramatically vary based upon your circumstances. I see customers all the time have this as a one-time expense that they write off, or they go more on a lease model where they accrue that cost every year. So these could be all the way down to zero for you if you've already written off these costs, or you may look at it as a cost where it's an ongoing cost that you're repaying for that initial license. So when we click save, the system regenerates all of the numbers. And lo and behold, we see something a little different now. All of a sudden, our Amazon cost, the bill that we would have paid to Amazon Web Services, has dropped from $4.5 million upfront down to $2 million. And if you already have these licenses, and these are really an accounting exercise around money you've already spent that you're allocated to spend anyways, this is a massive savings. You've just more than half your bill on day zero using things you already have. That makes everybody happy within an organization. And you can see here the algorithm also leveraged some of the very cool advanced techs that Amazon Web Services has. One of those things is what we call core deactivation. When you're bringing licenses to Amazon Web Services, we have the ability to actually turn off some of the cores on the EC2 instances, which allows you to actually reduce the number of licenses you need to bring over. Because we see, especially with SQL Server Enterprise, there's companies that have a very high RAM requirement, but not really a high compute, and Microsoft licenses at the core level. So the last kind of lever I like to work through with customers on kind of the initial pass-through is looking at their develop environment. Now, dev environments are special, especially if you're a Microsoft shop. Microsoft has something called they call Microsoft Developer Network, MSDN, And what that allows you to do is where you license your employees and they're allowed to bring their software with them. And that works not only on-prem, but that also works at AWS. Now, you can't run MSDN workloads or licensed people on any server, but the tooling here knows the rules and the restrictions, and so we'll do the right thing. So let's drill into the development environment. And we're going to create one last scenario. So in this case, we're going to go with test 3, and this is our dev workloads. So in this case, we're going to say the customer has MSDN. Pretty nice. And that's all we're actually going to do something a little different here. On premise, we know there's really no incentive to turn off your computer at night. That's not true when you're running at the cloud. If you choose to buy in a CapEx, it's true, it's the same. But if you want to go more in an OpEx model, Amazon will give you money back if you turn your equipment off. It's a pretty good deal. So in this case, let's model on demand, and we're going to see this new little widget that popped up here, which is called Dynamic Power Control. And what this allows us to do is to say, remember all those time and use that we saw before? We're going to leverage how the system automatically classified your workloads and layer in a base number of hours a day that infrastructure should be on. So for dev tests, I assume every server is on at least 9 hours a day. But if there's anything that was on more than that, keep it on because obviously people were using it. So this is a really nice, safe way to model what would happen if you took a power off first strategy for your dev or your dev test environments. So now we can go down and we see even a larger savings, which is really nice. We have now, since MSDN allows you to bring your Microsoft licenses, which includes the operating system, which includes all those SQL licenses, we've driven down that annualized cost from our production strategy, which is where we brought our licenses over. Actually, let's go from the beginning, from buying everything up front as a CapEx model, which was around $230K per year for your development, all the way down to around $100K per year. And if you're already paying for MSDN, this is within your entitlements. Bring it to Amazon Web Services. We will help you build up the right models to comply with licenses, and it just leverages everything you have already. So, what did we learn from this environment? The big things we saw was that by seeing actual utilization patterns and really more importantly, understanding the groupings of how your servers are deployed within your environment, we can apply different levers at AWS to really reduce the cost, the total cost of ownership. We saw a bunch of zombies, which resulted in reducing spend. And we also saw leveraging MSDN for those dev workloads really had a substantial reduction in the costing. So with that, I want to go back to Neeraj to talk about a case study that Cloud Economics was involved with.
Thank you, Gabe. Now let's pull together the full value story. Live Nation, the events promoter and venue operator, started their migration to AWS in 2016, which they did themselves. They completed the first 90% in 12 months and the remaining 10% 5 months after. They had two main objectives in moving to AWS. The first was around reducing costs, and second was to better support their business. The business case forecasted an 18% savings. As they migrated, they achieved 40% in the first year. Now, once they actually started to focus on cost optimization, running through some of the simulations that Gabe walked through, they actually achieved a 58% savings, and this is by year-end 2018. It was driven by a 50% reduction in traditional IT tasks. The team at Live Nation was now able to focus on cost optimization, and enable those really impressive results. In addition, they were able to focus on the top line for their business and take on new projects, which they traditionally did not have bandwidth for. For example, from a resilience standpoint, they improved their application level uptime from 3 nines to 5 nines and have had near zero performance complaints from their customers and business users. Live Nation reports a 10x improvement in their innovation pipeline. While SLAs used to be 6 months, they're now down to just 4 hours. In fact, business user satisfaction is now 90+%. Now, there's a few resources to help you get started. First, Gabe walked through a demo of the TSO Logic tool. In addition to that, on YouTube, we have a video that you can watch. We also have the online AWS TCO calculator, which can provide a quick back-of-the-envelope estimate in terms of the total cost of ownership difference between on-premise and on AWS. In addition, online, you'll find case studies and research. You'll find the Live Nation Value Realization Study, which we just walked through as an example of full value realized by a customer. You also find the IDC study, which I referred to earlier in the presentation, where they interviewed 27 enterprise customers. And finally, most importantly, don't forget to reach out to your AWS account manager. It's a great process to get you started on materials available, but more importantly, you can engage Gabriel and the TSO Logic team or Cloud Economics here at AWS. Thank you for your time today. Now, today we've explored a few areas of value that should be accounted for when developing business case. We particularly focused on the cost savings pillar and defined the different cost drivers when it comes to a total cost of ownership analysis. Gabe walked through how customers can use TSO Logic to understand their true infrastructure utilization on-prem and to model out what the costs would look like on AWS, as well as using a cost-effective Windows licensing strategy. We will now open the session up for Q&A.